Hi friends, so welcome to Amit Tech Journals, and we are going to talk today about ForkJoinPool and ForkJoinTask. So let's begin. So if you see the hierarchy of ForkJoinPool, it's a concrete class which extends java.util.concurrent.abstract executor service. Okay, and it implements the executor and executor service interface. So by looking at this hierarchy, it is clear that ForkJoinPool implements all the methods which are declared in executor service. So what is unique about ForkJoinPool? Let's see that. So basically ForkJoinPool, it's an executor service to run fork join tasks. Okay, we'll look into what are fork join tasks, but before that, this works on work stealing algorithm. Okay, what's that is all threads in the ForkJoinPool attempt to find and execute the tasks submitted to the ForkJoinPool by themselves. You don't have to write any extra code to assign any specific tasks to any thread. Okay, so we talked about ForkJoinTask. So again, if you see its hierarchy, it implements, it's an abstract class which implements a future interface, and it is further extended by two abstract classes, which is recursive action and recursive task. Okay, so let's see each. Recursive action. So these are the ForkJoin tasks which do not return any value. Okay, so when you have to use the ForkJoin task which where you do not need any value to be returned, go for recursive action. Recursive task, these are the ForkJoin tasks which returns any value. Okay, and the final merged value of the main task done by the subtask can be accumulated by the call of join method. What I mean to say here is that if you have a big recursive task, you can break it into subtasks. Okay, and again, that's each subtask can be further broken down into further subtasks, and all this is done recursively. And at the end, at the granular level, whatever subtasks you have, you want to accumulate all the values that are written by each subtask, then this can be done by the call of join method. Okay, we'll see now this ForkJoinPool and ForkJoinTask in action while solving these two problem statements. So the first one is that I have to print the integers in a list after multiplying them by 2, which means if my input list is containing 1, 2 and 3, my output should be 2, 4 and 6. 1 multiplied by 2, 2 will get converted to 4, and 3 by 3 to 6, right? It's my first problem statement. So the next one is that I have to print the sum of integers in a list after multiplying each integer by 2. So again, if my input list is 1, 2 and 3, all the integers in that list will first be multiplied by 2. So 1 will get converted to 2, 2 to 4, 3 to 6, and I have to then sum them up. So 2 plus 4 plus 6, I should get output as 12. Okay, so now let's see some code how to achieve this using ForkJoinPool and ForkJoinTask. Okay, so let's talk about a first problem statement where I have to simply, whatever integers are there in the list, I have to just print them after multiplying by 2. Okay, so I have to just print them. I don't need any return value, so that's why I'm going for recursive action. Okay, so I have a class, my recursive action, which extends recursive action. If I'm extending this recursive action, I have to override a compute method. Okay, so I'll come to this, but I talked about an input list having integers. So this is that list. So to the constructor of my recursive action class, I'm passing this list. Okay, so this list is going to have integer values. Okay, so now coming on to the compute method. So I told that my recursive action which is a recursive action, which is a ForkJoin task. Okay, so now I told, like I can break my fork join tasks into multiple subtasks recursively, and then each subtask can be will be picked up by some thread in my fork join pool, and it will execute it. So the first thing is that if I have a big task, fork join task, I have to break it into multiple subtasks, right, recursively. So that's what I'm doing here. In the compute method, if you see, I have defined a threshold that if my digits list size is greater than 5, right? So suppose this digits list is having let's say 50 integers, okay? So its size will be 50, and as per the threshold it is greater than 5. So here I am creating the subtasks, okay? So let's see how I am creating the subtask. If you see this method, here I am simply creating two objects of list of integers and a list of subtasks of type my recursive action, and then simply I'm just taking the original integer list and I am splitting it values into two lists, list 1 and list 2, okay? And then I am creating two more subtasks which are of type my recursive action and passing to its constructor the splitted integer list, okay? So if my initial digits list was or the integer list was 50, my list 1 will have 25 integers, my list 2 will have 25 integers, and I am creating two subtasks each with 25 integers, okay? And then at the end I'm adding these subtasks to a list of subtasks, okay, and I am returning it. So take a pause, look at this method and see how one task is getting broken down into two subtasks, okay? Then after creating the subtasks, I am iterating over them and calling this fork method over each subtask, okay? So my subtask is of type recursive action, and I am calling the instance level method of recursive action, which is fork. So what this fork is going to do is it is basically going to call this compute again, okay? And again this thing will happen. So again the threshold will be checked. So my subtask is right now having 25 integers list, okay? So again this threshold will be checked and again subtasks will get created, okay? So 25 integers will get again broken down into two lists, one having 13 integers and other having 12 integers, and further it will keep on getting broken down, okay? So it's happening recursively, okay, when I'm calling this fork method. Fine. So at the end I'll have a subtask which will be having a list of size which will be less than or equal to 5. At that threshold, then what's gonna happen is further subtasks won't get created, and then I'm in the else block I'm defining what my granular level subtask has to do, what action it has to perform, wherein I'm just iterating over the integer list and multiplying it by 2 and printing it along with the thread name which is doing that action, okay? So again take a pause here, look at this compute method and see how I'm decomposing main fork join task into multiple subtasks recursively, okay? And how I am defining a threshold, how I am defining what my granular level subtask has to perform, okay? Fine. So now let's call this my recursive action. So for this I have a class demo. So if you see here, I am creating a ForkJoinPool, okay, by calling ForkJoinPool.commonPool, and then let me comment this out and let me uncomment this. Demo recursive action is a private method which I'm calling and passing this ForkJoinPool instance to it, which is here, demo recursive action. Here I am creating an object of my recursive action and I'm passing the list. So I'm generating this list here. If you see, it will be a list of integers having values 1 to 30. Okay, 1 is inclusive, 31 is exclusive. So a list of integers, and it will contain integers 1, 2, 3 up till 30. Okay, and then I'm coming back here. I'm passing this to the constructor of my recursive action. Okay, and then on this ForkJoinPool object I am calling this invoke method and passing to this my recursive action. Okay, so when I'm going to call this invoke method here, then what it's this compute method will be called, and whatever I explained will be happening. My main recursive action or the ForkJoin task will get broken down into subtasks recursively, okay, based on this threshold, and then each of the subtasks will be picked up by the available thread in my pool on its own, and it's going to process it. Okay, all I have to do is I'm just calling a fork method here. Okay, so let's see this now. Let me run this. Okay, now let's see the output. Just give me a second. Let me go to the console, copy this out, let me print put here, and let me remove the first and last line. Okay, and now let me copy this, and in order to analyze this, let me put it on an Excel. Let me delete this. Okay, so this is the name of my threads, and this is the output which each thread is printing. So in order to simplify it, let me sort it. Okay, so you see thread 1 printed these 4 integers 24, 26, 28. Why? Because the initial integer was 12, it multiplied by 2 and printed 24, it was 13, 26, like that. Okay, so that's how it's doing. This is my one thread. My worker thread 2 printed 4, again 3, again. So you see multiple threads were involved here, including the main thread. Okay, why multiple threads? I'll just try to explain there. So my initial list size was 30, okay, and then it got broken into 2 subtasks, 15 of with list size of 15 each, right? Recursively, again, this got broken into further subtasks. One will be having 8 integers, other will be having 7 integers. Okay, similarly this one also got broken, 8 and 7. My threshold was 5, so this got again broken into 4 and 4, right? And this got broken into 4 and 3. 7 got broken into 4 and 3. Similarly, this thing would have happened here as well. So if you see at the granular level, I had how many subtasks? I had total 8 subtasks, right? So that's why if you see the count of threads which got involved were 8. 1, 2, 3, 4, 5, 6, 7 and one main thread. So you see main thread printing 3 numbers only. Why 3? Because it picked this subtask. Similarly, thread 6 also printed 3 because it picked this subtask, and rest all threads printed 4 numbers. Okay, so you saw I had a my fork join task, and I broke it into multiple subtasks recursively, and my multiple threads which were in my fork join pool picked these granular subtasks and performed the action. Okay, so now going on to the problem statement 2, wherein whatever integers are there in my list, I have to multiply each by 2 and then sum them up. Okay, so here I need the end result, the summation of all integers after multiplying by 2. So when I want a return value, I'm going to use my recursive task, not my recursive action. Okay, recursive task, not recursive action. Okay, and I'm saying that the return value will be of type integer. So I'm creating a task, a class my recursive task, which extends recursive task. I'll again override this compute method. Okay, here I'll again do the same thing. I am defining a threshold, and I'm going to break down my fork join task or recursive task into further smaller subtasks. Okay, with the same code which I had shown earlier. So this create subtask is same. Okay, the only difference is I need to accumulate the results also, right? So for which what I'm doing is, after forking it, I'm also writing a code where I'm iterating over the subtasks and I'm calling a join method. Okay, so when you call this join method, then whatever each subtask it is returning some value, so that will get accumulated. So that's what I'm doing. I am adding all the return value of each subtask into this int variable sum. Okay, and that's what I'm printing it here. And when this threshold is will not be met, which means my subtask is having a list which is of size less than or equal to 5, then I am defining what action has to be performed. So if you see, I'm iterating on this and I'm multiplying each integer by 2, and then I'm accumulating it or reducing it to a one value by calling the sum method. Okay, the sum of all these integers after multiplying by 2 will get returned. Okay, by each subtask. And here by call of join, I am joining the results of each subtask. Okay, and at the end I am printing, I am returning the sum, which means the end result, which is accumulation of all the return values by each subtask. So take a pause here, look at this compute code, okay, and see how this fork and join works. Okay, now again to demo this, let's go back here, and this time I'm going to call this demo recursive task, and I'm going to pass the fork join pool again. Okay, so this thing will get called my demo recursive task. I am creating an instance of my recursive task. Again, the same list I'll be passing to it, which will have integers from 1 to 30. Okay, and I'll call this invoke method over this fork join pool. Okay, to to submit this my recursive task. Okay, and here I am taking the return value into a int variable, and I'm just printing it then. Okay, so when I call invoke, then again this compute will be called, and whatever I explained, that will be happening. So my recursive task will get decomposed into smaller subtasks recursively, and all the return values will be accumulated and it will be returned. Okay, so let's run this now and see it. So let me run this and let's see the output. So you see my main thread, it's printing some of the digits into 2 is 930. So if you take integers 1 to 30 and if you multiply each integer by 2 and if you sum them up, it will come out to be 930. But if you see the thread names which were involved, so you see the thread names are printed here 54262 Okay, so you again see multiple threads were involved in doing this in executing the granular level subtask. Okay, but my main thread was not involved in executing the subtask. Why? Because simply it was waiting to get the result, the end result. Okay, so that's a thing. Now at last I want to just very quickly cover when to use this ForkJoinPool, right? So basically ForkJoin, you should use it when if you have a, as I said, a big ForkJoin task and you have to decompose it into subtasks, keeping in mind that your subtasks, granular level subtasks, should perform relatively small amount of computations. Okay, and that's what I just told. You have to decompose your main big task into subtasks. Your each subtask should perform more than 100 and less than 10,000 basic computational steps and should avoid indefinite looping. So the basic idea is that you should keep on decomposing your main task into subtasks and further into subtasks until and unless you are left with only small computation to be performed by your subtask. Okay friends, that was about ForkJoinPool and ForkJoinTask. Thanks a lot.